that's what's going to happen when as these situations become more frequent in the future. These populations are more vulnerable, and so we actually have experience with that. And then also further research showing how vulnerable Africa is, both by being at a low latitude and having some of these desert-prone areas already, so by nature of its geography, and then also by nature of its low adaptive capacity, I think is what it's called. Yeah, low adaptive capacity. They can't adapt very well because they don't have the money or the resources. Yeah, and they're not getting it.
Reb, this is just kind of like a basic question, but on that last graph that you were just at, when it kind of showed, actually most of the graphs are in degrees Celsius, so maybe just to kind of lay it out degrees Fahrenheit, since most students don't really have a good
kind
of...
we're going to come back to that graph. So John was asking if we can translate this Fahrenheit, and we're going to come back to the graph and do that. And then, so now we know, we've seen evidence now that we're more vulnerable, and then also there's more evidence that small temperature rises can put us across tipping points. And this is particularly with regard to the ice sheets, so Greenland and Antarctica, and particularly West Antarctica, because the base of West Antarctica is below sea level, which means you start getting warm ocean water in there, and that can cause disintegration, whereas East Antarctica is sitting high and dry on land, which makes it more stable. So better assessment of and I think we talked about this a little bit in August, the issue that even the IPCC in 2007 basically punted. They were like, we don't want to deal with this at all. It's dynamic change in these ice sheets, really hard to get your hands around that. So there was this paper that came out that tried to put some numbers on it that gives a better idea of dynamic change of those ice sheets. And then also medium confidence that a degree to a degree and a half temperature rise could cause partial deglaciation, which is disintegration of Greenland and maybe West Antarctic ice sheet over hundreds of years to thousands of years. So that commitment warming on a really big scale, or commitment changes that we're have in store for us no matter what we do. And that's 4 to 6 meters sea level rise in one of those, in West Antarctica or in Greenland, either of them. So and then also more evidence for stronger feedbacks in the carbon cycle, too, is another part of this, and that's that permafrost melting. Yeah. And I think that this just keeps getting back to the point that, and it's I think about this all the time, that, it's not we're exaggerating the science, it's the more science you know, the worse it gets. And that just sucks. So let's look at slide 11 now, back to these diagrams are called the burning embers diagrams. That's what they've been called. And so looking on the left one, back in 2001, so here, let's put on here this 2 degrees C line that a lot of people talk about. And so this is why it's not at 2 degrees, right? Because this is 2 degrees C since the Industrial Revolution, as opposed to their 0 mark, which is today. So if you look at the left one, on that one, 2 degrees looks pretty good. And so back then, 2 degrees C was considered and so 2 degrees C is 3.5 degrees Fahrenheit. That was considered pretty conservative. If we got 2.5 degrees, and this was also 8 years ago, right, where we had a bigger window of opportunity, so we thought maybe we could shoot for more conservative, safer estimates and goals. That one was looking great. It was sweet, yeah, stay below 2 degrees C, and we are in the green zone, we're clear. And now we move over to the right-hand side of the graph, and you get to below 2 degrees, and we still have red there, which is severe risk to unique and threatened systems and extreme weather events in particular. And it's starting to show the distribution of these impacts being more widespread than it had before. Another thing, if you look on the transition from the left, the 2001 estimates to today's, you see on the left one, there's a lot more yellow in there. So there's a lot more of this broader switch from oh, it's not so bad, yeah, it's getting kind of bad, okay, now it's bad. But if you look over here, especially on these first 3 reasons for concern, it's we're getting better at narrowing that window down where we know we're moving into pretty serious risks. That range of temperatures that we can play with is getting smaller. So yeah, there's just right around 1 degree there. It goes from yellow to red pretty fast. So better knowledge, and that yeah, we have less wriggle room than we thought we did. And so back in 2001, when 2 degrees C was considered like really safe, a lot of people then talked about the doubling of CO2, the 560 or so parts per million, as that being like a just sort of commonly discussed benchmark for us to try to go for. And that means, and based on, what does that translate to in temperature? That depends on the climate sensitivity, but that general climate sensitivity for the doubling was 3.5 degrees. So Celsius. So like, what's that, like maybe 6 degrees Fahrenheit? And so now we're looking at that and we're like, no way. So put us on here in terms of 3.5 degrees. Like, we're way up there now. So that as we've learned in the last 8 years, like now, as we've run out of time, like we've learned more about the consequences. They've started to get worse. Did you have a question?
Fred, can you explain why our benchmark, or why that line is at 1.5? Like, where did you get this number, or did you just pick it just to look at how much has changed?
Yeah, so it's at 1.5 on this graph because that's the same as 2 degrees Celsius since the temperatures at the beginning of the Industrial Revolution. Okay. So there's a difference between the two, this temperature scale on this graph, which is using 0 being today's temperature, and what a lot of, like, I think that the commonly used terminology is comparing temperature to pre-industrial. So that's the difference. So I know, so I went in and said, like, oh, everyone uses 2 degrees C, and when they use 2 degrees C, they're talking about 2 degrees C since pre-industrial, and then this graph goes ahead and does something totally different, which is kind of terrible. So that's why I drew the line there, because that line is actually 2 degrees. Because you see that little negative 0.6 that's hiding down there at the bottom, and that's what we've experienced already. Yeah. So it's the same thing as a 2 degrees C line right there. And so, yeah, so this number that like a lot of people talk about, 2 degrees C, it's like, first of all, even if we shoot for that, we're still kind of screwed in a lot of ways. Things are looking not that good. And now let's turn our attention to, like, is this even possible to get to 2 degrees C? So we've sort of defined dangerous, and like if we, in an ideal world, we'd probably bring dangerous, I don't know, where would you guys put the line for dangerous here? Below 2 degrees?
Yeah.
Yeah, I think in some, like, 1 from now, which is like 1.6 compared to pre-industrial, also looks like getting close to dangerous. And we've got that graph I showed you a few slides ago that's like we're already committed to over 2 degrees. So like, maybe we're there already, or more than there already. Yeah. Other thoughts?
Now's the time when you're like, I didn't come here to bum you guys out.
But it gets worse.
It gets worse, yeah.
Okay, so now we get to go to slide 12. This should be slide 13. This is the reality check.